Okay, so it is now 9:30. Let's go ahead and get started. All right, so let's begin with questions. All right. Okay. So back to the right, and 1 over. So tau, right? Yeah, so what is your question?
I have a question about feature engineering.
Uh-huh. That's what we're talking about today, so that's good.
If we're doing, say, part of the speech tagging, and then some people say that if we design features like black art,
Mm-hmm.
then what are the basic principles we can follow?
Right, so, I mean, if there were basic principles that would have been covered in the lecture, I would hope, or you should hope that at least. So I think that the basic idea is that you need to have an iterative process for doing classification. So you have your data. Oh, this is a little wobbly. You have your data. You make a classifier. And then you inspect what's happening. And so you can, how do you inspect this? You can look at the features that get used. You can look at the accuracy. You can look at individual examples. And you basically need to look at these things and see what is going wrong. And from that, you need to figure out a way to repair your classifier so that it gets fewer things wrong. So let's go through each of these. In inspecting the features, you might see that a very common word is getting highly weighted as a feature. And so that's a common problem that happens. And if that happens, then you basically say, don't use the as a feature, if you believe that it's not useful for whatever classifier that you're using. And so I'll do a lot of languagey examples, but this also holds true for vision or whatever else as well. Okay, and looking at the accuracy, you might try, well, let's add in this feature, and if it tanks your accuracy, then don't do that. And you can try out lots of different things and see how it impacts your accuracy, and if you get, if you do 2 separate things and each of them individually increase your accuracy, you might want to combine them in some way. And then on examples, you should look and see what's getting right and what's getting wrong, and see if you can fix it to add a new feature that somehow encapsulates what's going on with that example. So it's not a cookbook, and this is why today is going to be a more open-ended discussion than other classes where I give you a worksheet and there are these rules that you work out and you come to an answer and you're done. We're not going to be doing that. It'll be a more open-ended discussion today. So, yep.
So if you're supposed to just like keep trying all these different combinations to see what maximizes your accuracy, why don't we just automate that process and say,
yeah. So
accuracy of all of my possible combinations?
Right. So that's an excellent point. So you can do that to some extent, and that's basically what the whole deep learning thing that we'll talk about in October is about. So how do you automate that in some way? So yes, you're absolutely right. Can't somebody else do this for me? And so yes, there are ways to do that, but computers aren't quite as clever as we are, so there is still a lot of room for human intuition in this process to look at where stuff is going wrong and craft a feature to fix that problem. So yes, to a certain extent, it can be automated, and so we'll talk about that in deep learning, and there are nice things like Vopal Wabbit is a nice is a nice package that does quite a bit of this for you in searching for features. It's a nice industrial strength package out of Microsoft. So it does a lot of the stuff. You can use it and get a lot of that. Yep.
So, for one thing, if some problems may have a large enough set of features such that trying all combinations of every possible feature can get unfeasible.
Oh yeah, and
so you have to
yeah.
some way of choosing some subset or some combinatorial subset.
Yeah, exactly, and so that's an excellent point. Sometimes there are just so many features it can't be done, and automatically, and this is where human intuition can help.
Right. And my other question was regarding. So I know with things like linear regression, you can do some analysis on your variables. You can see if there's some kind of confounding factors between some of your multivariate factors. I know with the video was about like speech, for example, speech recognition. For example, you can do things like stemming for verbs or
yeah, exactly.
But I guess my question is, for more numerical attributes, what about things where you can get derived data? So, for example, if you have street address, city, and state, you could derive lat long. You could get zip code, things like that. Taking those approaches, I mean, is that generally something else to consider?
Yeah, absolutely. And in the old version of this lecture that I used to give, I had exactly that as an exercise. But I ended up removing that because it was fiddly, and you basically had to make an API call to Google Maps to get the latitude and longitude, and that broke like 10% of the time, and it ended up getting annoying. So I ended up swapping it out for what you saw. But yes, absolutely, you can and should do that. And I think one problem that a lot of people have when they're just starting out is they treat classification problems as homework problems, that I have my data set and I have to use that and nothing else. And I think that one thing that really separates sort of novices from experts is being able to see connections between data sets. And so I have these addresses. Aha, if I make a call to Google Maps, I can get a latitude and longitude, and then I can turn discrete information into continuous information. In that version of the class, the goal was to predict how long people would take on a bike ride from point A to point B. And we had some nice data from basically a bike sharing service. And one of the biggest features that ended up being useful for the team that won the competition was the elevation from point A to point B, which was not in the data set. You just had addresses. But if you plug that into Google Maps, you can get the latitude and longitude and the elevation of a location, plug that in, and you can do a great job of predicting how long people will take to get from point A to point B. So yes, absolutely, think outside the box of your data set and try to do neat stuff. Yep? Outside
of memory constraints, is there ever a problem with having more features, like false positives?
Right, so that is an excellent question. So there is a phenomenon called overfitting, where as you add features, so let's say this is num features, or mum features, I guess. Your accuracy goes up, goes up, goes up, goes up, and just keeps going up on your training set, and everything looks great. But on your test set, your test set will lag behind, and if it starts looking like this, you have overfit. And so this delta is overfitting, and it is a common curse of feature engineering. If you just throw the kitchen sink in, you can imagine that you're adding in features that basically say, this is example 41, and say yes for this, and you'll get great training accuracy. And so you don't want to have features like that, features that don't generalize well. And so how can we combat this?
Well, I was wondering, how do you tell the difference between the fact that you're
Right, yeah. So that's an excellent point. So let me come back to that later. And if I forget, yell at me. But that's a good point. So what have we talked about that would prevent you from using too many features? I heard mumbling that sounded right. Yeah, regularization. So regularization is one way to combat this, that you have something in your model that says don't overuse features. And so if you have regularization and you throw a bunch of features in, you are usually, with some exceptions, fairly immune to overfitting, but it is something to be aware of, and so you should have a held out set where you're tracking how you're doing on your development set, just to make sure that you're not falling prey to overfitting as you add in bunches of features. Excellent question. But yes, usually more stuff is better. So yes, should I do the overfitting versus representative stuff next, or is your question a direct follow-up?
No, sorry.
Okay, all right. So now let's do this. Overfitting versus representativeness. So this is a really tricky question. There's no simple answer to this, but I will give something that sounds like an answer. So one thing that you can do is you can split your training set and break off a little development set and compare that with data that you collect in another way. And if what you split off from your training set and what you collect in another way sort of give you similar performance, then that's a good sanity check that you're doing something okay, that it's not totally unrepresentative. But that is only sort of brushing the surface of the problem. So does that answer your question? Okay, all right. Yeah, and like I said, this is a major problem in the real world, so it's not going to be an easy answer. So, yep.
There's a discussion about the cursor dimensionality on the outside.
Yeah.
And in it, you mentioned one of the solutions was adding more dimensions, and you said...
Yeah, exactly. Yeah, right.
Are you saying to replace some of the dimensions you had with engineered features, or adding those on top?
Yeah, so usually it's adding them on top, and so long as you have regularization, it isn't too big of an issue. So you add the features on top, and hopefully they're useful. The classifier uses those new features and ignores the old stuff. But if the old stuff ever happens to become useful, then it can go back to that if it so chooses. Yep.
So I guess following on about the overfitting versus representational thing, it's generally a good idea when you're starting to learn on a set, you want to know things about your data, such as like if there were temperature data for a station, you know, the extremes, the min, max, averages, things like that. Don't you want to do some kind of pre-analysis to get an idea of where it might fit?
Right, and so that's an excellent point. So one thing that you can do is you can know that stuff yourself. However, one thing that you can do to let your algorithm know what's going on is to standardize all of your data. So if you have x1 to xf, as a feature, what you can do is you can transform each of these into x1 minus x bar over the variance of x. And so now everything has mean zero and unit variance. So this is a way of encoding information into your classifier so that it knows, I see a temperature of 23 Celsius. Is that high, low? Is that an extreme outlier? Should I pay attention to this?
Right, okay.
So this is if you have continuous inputs, this is a nice pre-processing step to give that information to your classifier so that it does reasonable stuff.
Right.
Excellent point. Yep.
In this case, we are using standard on
Mm-hmm.
You know, the standard distribution function. So to figure out the which variables are post scaling.
Yep.
Left on the right, and we then make a complete probability for the area under graph, which have larger area, like that.
So, I mean, while we're making it look normal, we're not really assuming anything. It's basically just a way of representing to the algorithm whether something is above average, below average. We're not assuming that it's normal or anything like that. It sort of makes things look more normal, but it can still have crazy distributions. So it's not, you can do fancier things, but this is quick and dirty, and it often works well.
And we use overfitting, and is this similar to the feature engineering that we have to neglect some features which apparently which have to include and which do not include?
Yeah, so after you've done this, it's much easier to do additional feature engineering on these features. So for example, now you can multiply two features together, and it makes a lot more sense. Yep.
So this is about regularization. In the logistic regression class, we multiplied the weight by a constant factor to regularize it.
Mm-hmm.
And in the code that you mentioned in the lecture, there was some L2 regularization that was used. Are these two the same?
Yes, L2 and the stuff we're doing in logistic regression, they are equivalent up to a constant.
Okay.
We'll get into other forms of regularization that aren't mathematically equivalent. So L1 regularization, for instance, actually counts up the number of features that you're using and uses that as a regularization term. So while L2 encourages your feature weights to be small, L1 says turn them off, set it exactly to 0. And oftentimes that works a little bit better in terms of having a sparse model.
Okay. And also, what was the intuition behind the exact constant that we multiplied it by, 1 minus 2 mu lambda?
I use a lot of constants. Which
in the regularization,
Uh-huh.
we multiplied the beta by 1 minus 2 mu lambda.
So lambda is the step size.
Yeah.
Mu is the regularization term. The 2 came from the L2 regularization, so it's the 2 norm. So when you take the derivative of that, so
okay.
dx squared dx equals 2x. So that's where the 2 came from, just taking the derivative.
Okay.
Yep.
Does feature independence have any effect on the algorithm? Say some features can have common data inside them. So what is the impact on the algorithm as such?
Right. So let's think about this in the case where they're exactly identical. In that case, it's silly for the algorithm to use both of them. And if you use L2 regularization, what will happen is it will do the silly thing, and it will use both of them just a little bit so that it can get a big value for both of them, and it's not spending too much of its budget trying to make that big. So this is where it would make more sense to use L1 regularization, so it would just use the 1 and not have 2 small weights on 2 correlated things. So it really depends on your regularization what happens. And in an unconstrained model, who knows what will happen? If you have no regularization whatsoever, it can interpolate fully between the two. So it can use none of one and all of the other, or it can interpolate back and forth and use however much it wants. So that makes it bad for looking at the features afterwards and trying to understand what's going on, because you might run it twice, get 2 very different answers that work the same way. So that's bad. So in that case, it's better to use L1 regularization. It'll be a little bit more stable in choosing one and only one of them. That said, in terms of performance, it doesn't really matter that much. So it'll still do an okay job. And you'll get decent accuracy, but it will make doing feature engineering more difficult. Excellent question. Yep.
In your cases, adding features always increase the accuracy. Decrease precision or recall rate. Should we add it?
It depends what you care about. So thus far, we've been making the assumption that you care about accuracy. But if you actually care about precision or recall or dollars that you get from your advertising budget, then yes, optimize that. So optimize what you care about. It doesn't really change too much the algorithm that you use. Okay, so we now have a face on our Zoom. Did you have a question, or are you just popping in? So I'm still getting used to the setup. So hello, yes.
And what is the cost function for feature engineering, like in that cases, in the terms of accuracy?
Sorry, one more time?
What will be the cost function for feature engineering in terms of accuracy?
Right. So, yeah, so logistic regression explicitly optimizes log likelihood, which correlates with accuracy. So if you want to use, you need to do like held out evaluation of that metric. But we'll get to other algorithms that explicitly optimize something else like precision or recall a little bit later. But right now, it's still using the original objective function. Yep.
So this is not directly related to feature engineering as such. It was, I wanted to know how does giving more passes on the data, getting more passes on the data increase the accuracy? It's essentially looking at the same data over and over again, correct?
Yeah, exactly.
But how does it increase the accuracy the more it looks at it? It's
right, so there are a couple ways to think about this. So one way to think about this is, let's go back to our example of someone trying to get to Union Station. It could be that one person is really informative, and when you ask them, they always give you the right answer and point you in the right direction. You don't know who that person is, however. And so as you're building your model of figuring out what is the right direction to go to Union Station, you walk around, you keep asking people, and your arrow keeps changing. And so when you talk to people who give you the right direction, you get closer to the true direction, and other people point you in the wrong direction. You don't know which people are the most valuable until you have a good idea of what direction you're going. And if someone is pointing you towards the mountains, then they're probably not so useful. In subsequent passes, you know that, and you pay less attention to them. And so that's sort of what's going on here. You're able to use information from better people more efficiently when you yourself have a good idea of where you're going.
So in terms of what we learned, it's probably the initial bias over every pass keeps getting better as we.
Yeah, well, so I mean, okay, so that was the intuitive way of thinking about it. Mathematically, you're doing some sort of hill climbing, and so as you get closer to the optimum, you're changing fewer and fewer coordinates. Very much, and so your deltas keep getting smaller and smaller and smaller, and so each time you see a person, there's only so much information they can tell you. Remember, each person or each observation only has a subset of the features, and so you're getting information about a subset of the features early on. All of those are going to change quite a bit. Later on, you're taking smaller and smaller steps. But you're now learning how to use each feature better and better. Yep.
So is there?
In the middle first. Yep.
If you go through the same data set again and again, it leads to overfitting, right? So overall, the generalization error increases and.
There is no hard and fast rule about this. You can overfit, absolutely, and so. There are heuristics called early stopping heuristics that say, so basically have some development set, see how you do on that development set, and after you've reached a certain point on that development set, stop. And so see what the best is that you've done on your development set and stop after that. But sometimes just keep going over your data. You asymptotically get better and better and better. It really depends on your data and your models. So there's no hard and fast rule about that. Did you have a question?
There are conditional probabilities are increasing, like relative probabilities are increasing depending upon the other variables.
Well, so by definition, your log likelihood on your training set will increase if you do batch gradient descent. If you do stochastic gradient descent, it will increase on your mini batch. But there is no guarantee about the global log likelihood if you're doing stochastic gradient descent. Yep.
In the regularization, we try to diminish the weights.
Mm-hmm.
And in our example, we just minus 2 lambda mu times beta.
Yep.
We use the new beta in this iteration, but maybe in some versions we can minus the last beta in last iteration. What's the difference, or what makes a difference? Semi-practically.
Yeah, so there's so one way of thinking about this is that the feature weights can have some momentum. And so some features you see a lot, like the feature for you're going to see it a lot. And when you see it in a new example, it doesn't really matter much. You're not going to learn very much. Some words are far more rare, and so you need to be more flexible when you're learning those. And so in those cases, there are clever things you can do, like taking trajectory into account. That goes beyond the scope of this class. There's a very nice paper called Attigrad that talks about this exactly. And so it says have separate learning rates for separate features, take the trajectory into account. And it's very mathy, very rigorous. This is a lovely paper by lovely people. I encourage you to read it. It's a little bit beyond the mathematical depth of this course, but really useful, and it gets to the intuition that you were saying.
So in our example and exercise, we just minus the new beta covered in this iteration.
Exactly, yes. Yep.
Regarding the, specifically in the terms of language, regarding the independence of features, like one example you had given was if meeting is preceded by it has more likelihood to be a noun.
Yeah.
Are there models that do this implicitly, or is this always done by feature engineering, who look at what is going on around it? And
yeah, so I mean, you can extract all bigrams, and we'll have an example of that in a second, and then you can see which of those bigrams are useful. So for arbitrary length stuff, there is some complicated statistical things that you can do to search for strings of arbitrary length, and use those as features. We had a paper called Pittman-Yor Naive Bayes that did this. It improves accuracy a little bit, but frankly, it isn't really worth the computational cost. But I have this paper on my webpage if you want to take a look at it. But I don't recommend it to anyone to use. It's horribly complicated and really not worth the effort. Okay, so if there are no more content questions, let's go to administrivia. So homework 1 should be turned in, yes? Okay, so how did people feel about homework 1? How long did it take people to do?
Half an hour.
Half an hour? That's what I want to hear.
Actually, that's not true, because I ran a bunch of trials of the full data set. And those
well, but that's not your time.
Yeah,
that's
writing it, probably half an hour.
Yeah. So that's what I wanted to hear. That's the right answer, as it were. Yep.
one thing to fix bug fixing in the future is to just, I thought the confusion matrix was only for mislabeled.
Yeah.
And so it was kind of confusing. It should be noted that it's actually for both mislabeled and
Yeah, yeah.
That's my only suggestion.
Yeah.
But it was like 30 minutes. Yeah.
Okay. Yeah, so hopefully that was true for everyone, and if that wasn't true for you and you're not brave enough to say that now, come talk to me and let's figure out where the issues are. So the next homework is ramping up the difficulty a little bit. It's about halfway to the normal difficulty of homeworks. So it's not too bad, and it's fairly representative of the difficulty going forward. Homework 3 is very different than homework 1 or homework 2. I don't tell you what to do, and this vexes some people quite a bit. So in homework 3, you have a data set, and you need to do classification on it, and you need to do feature engineering. I don't tell you how to do it or what to do. There aren't functions you need to fill in and things like that. There aren't slides where if you match what's going on the slides, you'll be fine. You need to have a little bit of creativity. And also, there is no one right answer. It's a competition with everyone else in the class. So your peers tell you how much work you need to do to get lots of points. So if your peers are lazy, it'll be easy to really get lots and lots of points on the assignment. If you do a reasonable amount, everyone will get full credit, but the only way to get extra credit is to beat your peers. So hopefully that will be fun, but it does require sort of a different mindset. You can't just sort of sit down and have a checklist of things you're going to do. You need to be a little bit more creative about it. There are also time constraints built into the submission platform, so you can only submit some number of submissions each day. So if you wait until the very end, you'll only be able to make a limited number of submissions to the platform. So don't leave it to the last second. You won't know how you're doing on the held out data. Okay, so those are all the announcements that I wanted to make. Administrivia questions. So one question that did come up earlier is there are 2 videos, at least at this point, that aren't on Echo. So the one for today that you hopefully watched, and also the one for Rademacher complexity, which is in a week and a half. So in those cases, there is a direct link on the course webpage to those videos to watch on YouTube. They're not in the ecosystem because they were recorded elsewhere. So click on those. They're the exception rather than the rule. I realize that it's annoying, and the problem is I can't link directly to the Echo videos from the course webpage. So just check those out. Hopefully not too bad, and some people asked about it on Piazza, and feel free to do that in the future. Other administrivia stuff. Yep.
So for like evaluating extra credit,
yeah.
So like what I did was like added like a Boolean value for like, step size, for instance.
Mm-hmm.
So that way like my function still passed the tests, but you can get like a better better iteration step if you say like something true. Is that like is that kind of what you want to see? Like, how is that evaluated? Like,
right. So you should not break the API, and so the way to implement that is to change the step size function so that it doesn't return the same constant every time. But I don't want to say too much about this because the grader will be the one to grade it. So you should ask on Piazza and get the appropriate grader to give you the one true response. If I were grading this, I would say I would prefer to have subclasses. So like take your original class and then subclass it to add additional functionality. But this is a better thing to ask on Piazza and get the grader to respond, because they're the ones who will be doing it. But that would be my uninformed take on it. Yep.
This is kind of a question about the homework assignment.
Mm-hmm.
But
which one?
The logistic regression.
Yep. Mm-hmm.
So in all the examples that we went through in class, lambda was a constant value, and then it's implemented as a function in the homework.
Yeah, so that's for the extra credit.
Okay, but what is that a function of?
The iteration.
Okay, all right.
Yeah, and so basically what you can do is you can have the step size go down over time, and that will often lead to a better result.
Okay, thanks.
Yep.
Are we only able to do it as a function of iteration?
As provided by the API, yes. So you cannot do what Adigrad does. But then it becomes a function of both the iteration and the feature and the history of the feature, and then it gets way too complicated. Yep.
Question on the pre-class lectures.
Yeah.
Would it be possible with future math that gets displayed and explained to have a really quick example problem as well? Because I know some people have been having trouble with that.
Well, so that is what we do here. I try to add that occasionally, but that's really what this time is about. And you'll have tons of that in here. Less so in the videos because I feel like, this is my own personal philosophy, that you can get sort of a gestalt from looking at it and hearing it, but you don't really absorb it until you do it, and that's what we try to do here. So that's my philosophy. If you're not getting enough, then that's another question, and then post on Piazza, and we can provide more examples.
That's great.
But the goal for the videos is that they're relatively short and dense, and for this time to be used for examples and things like that. Okay. All right. So now on to the main event. What I thought that we would do is talk about a different data set and how you might go about exploring features from this data set. If you want to play along, there's a link on the course webpage to this data set, and you can run it through the same classification code as for homework 3. But the way this data works is these are questions from trivia games. Each question is divided into one of about 8 categories, and it's important to know which is which. And so one of the things I do for research is try to make machines that automatically answer trivia questions. And one thing that really helps to know how to answer a question is this a history question? Is this a literature question? Is this a question from popular culture? You can have very different kinds of answers in those settings. And so if you're talking about the President of the United States, and this is a question about the television show West Wing, you would have very different answers than if this were a history question or a novel by Philip Roth about President Lindbergh, for example. And so if you know the category of the question, you can do quite a bit better. Okay, so let's start with a very simple set of features. And so here this is each of our categories followed by a colon, and then the features that have the highest logistic regression weights come after that. So let's pretend that we're doing feature engineering. You run this and you get accuracy of around about 77%. So what observations can you see out of this? What might you do to improve these features? What's going on here that strikes you as odd?
There are repeats.
So like what?
Under astronomy, you have objects twice.
Not exactly. So there's objects and object.
That could still be an issue.
Yeah, exactly. So how might you fix that problem?
You're not allowed to modify the data set, I'm assuming?
No. Please modify the data set. So be creative. Do whatever you want. Go crazy.
Yeah, just remove the plural version of it then.
Yeah, exactly. So and then these are called stimmers or limitizers. So you can certainly do that. Okay, what else is going on here?
You have like biology, chemistry, physics, and you still have science.
Mm-hmm. Yeah, so that's a good point. Often you can't change your label set, but if we were in sort of a more real-world setting, you should go to the person who gave you this data and say, hey, this doesn't make sense. We have things from astronomy and physics in the science category. We should get rid of one of these categories. Yep.
Is there an actual other category?
Yes. Yeah. Which is mostly popular culture, as you can see from Oscar.
I was just thinking it might be more accurate if you
Yeah.
break down other into what those actual categories were.
Exactly. Yep. So what else is weird here? What else might lead to what else might you do to improve what's going on? Yep.
2011 under geography seems like a pretty specific date.
Yeah. So any ideas about why this is happening, or how you might fix that? Yep.
So it might be that the training data contained only this specific year, so we might, and then use a regular expression to get all the years into geography probably.
Right. So the reason that this actually happens is that geography changes, and so like people say in 1998 this was the largest country, and so their geography has its tendency to sort of be legalistic and say exactly the years that this is true. So that's why this is appearing here. So you suggested maybe you could use a regular expression to get rid of this. You certainly could. Are there categories where it might hurt you to get rid of regular expressions?
History?
Yeah, history. History deals with dates, and so you might want to have a look at how the different categories so write your regular expression and then look and see how those things appear in each of the categories, and maybe you can embellish your regular expression to find one but not the other. Yep.
Another thing I noticed is that there are a few words that appear under categories that could go in multiple categories. Like under literature you have Jew, which could go under social science or history as well.
Yeah.
But I'm trying to think of some way to like combine the features without like making them just one feature.
Aha, yes. All right. So that's exactly what I wanted to hear. So how might you do that? So why is Jew appearing here?
You have a lot of World War II literature or something?
So that's one reason, but I looked at this a little bit because I saw this too, and it's actually happening because of Shakespeare and the Jew of Malta. So that's a title by Shakespeare. Yep.
So we can include as a feature the context around the word?
Yeah, exactly. So let's add in bigrams. And so now we've done the same thing, and all of our features are bigrams, one word that appears after the other. So what do you see going on here? So before I ask that question, everyone clear on what the features are? So take all pairs of words, and now those are your features. Yep.
Are you shifting your pairs by 1 or by 2?
By 1. So if you have I am the very model of a modern major general, you have I am the, and so on. So you have all of those. Yep.
You've got a lot of common words. There's a lot of this, the, of, etc. that are in a lot of different diagrams.
Yeah, exactly. And so is it really important that we have the universe? Does that really change what universe is? And so how might you address this?
Lots of speech.
Yeah, so you could do that, or there's also a simpler thing you could do.
Stop words.
Yeah, so you could remove stop words, but sometimes stop words are important. So like if you have Jew of Malta, of is a stop word, but Jew of Malta, putting that together, that's important. So what have we done here? What features have we removed that we had before?
Individual words?
Yeah, individual words. So the accuracy goes up a little bit, but if we add in both individual words and bigrams, and we can go to, universe went away for some reason, but there are other things that used to have the, the poet used to have an article. That has now gone away. And so once you throw in both unigrams and bigrams, the model gets to choose, do I want to use this in a bigram or do I want to use this in a unigram? And it ends up doing better, not too much better, but a little bit better than just bigrams by themselves. So what do you see going on here that seems interesting? Yep.
Well, I mean, it seems odd that you have all of these things that are like a subtag, kind of like someone brought up before. You see, when you have biology, physics, chemistry, earth science, astronomy, which are all parts of or types of a science.
Yeah, exactly.
It seems like it would make more sense to me to have it tag things like as science and then try and find the best one under science.
Yeah, that's a good point. Unfortunately, while you get to do whatever you want with the features, you usually don't get to change your tag set.
But can't you just change the way that you construct the features in the tag set?
Yeah, absolutely. And you might end up doing better that way, yeah. So what else is weird here?
There's actually very few bigrams.
Yeah.
Which is,
but,
what we were saying before.
Yeah.
You have city space S under geography, which seems like it just stripped the apostrophe out or something.
Exactly, yeah. So we have tokenization errors. That is...
Same thing with BC, I think.
Yeah, so there we go. Yeah, so think about the entirety of your pipeline, and so if you're getting things like this, you probably had some regular expression to find tokens, and you got rid of your apostrophe. So this may or may not be a problem. Yep.
We still haven't eliminated that problem that I mentioned first. Like under social science, we have psychological and psychologist.
Yeah, exactly. So I have no slides that implement your suggestion. So, but yes, absolutely right. We should use some sort of stimmer or limitizer to get rid of that. Yep.
I want to get rid of the points denominator.
Yeah, right. So we have things like for 10 points name and 10 points here. And these are basically stop words that are specific to this corpus. And these really don't tell you what kind of category you're talking about. All of these documents have this, but it's creeping into top features in some cases, and that may be hurting your accuracy. Yep.
So science has this number, and so what might have influenced that to go in science instead of mathematics?
Right. So these are labeling issues that some mathematics questions got labeled as science. Really, what I should do is I should clean up my data set and get rid of this, either merge everything into science or fix the problems with the stuff that's labeled as science. Yep.
Another question I had was, in science there is an electron. Surely every time this word must have occurred, the unigram electron must have occurred on its own too.
Mm-hmm.
So does the model feature bigrams over unigrams?
Both. And it chose to use an electron rather than electron by itself. And maybe this is because maybe you don't say scanning electron microscope, and so there are some contexts where you don't have an in front of it, and those are more associated with other things. And remember, we're only looking at the top 10, and other features are in there. Every unigram and bigram has a weight. Yep.
So two things. First, you have in other, and I saw this on the other ones as well, you have YR and then RL.
Mm-hmm.
Which seems really strange. And YR, I think, was paired with, like, American or something earlier.
Mm-hmm.
Which seemed very strange. But also, you have in science the phrase such as a bigram.
Mm-hmm.
Seems really not what you want.
Yeah, right. So, any ideas about YR and RL here? Yep.
Like YR year?
So I actually don't know the answer to this. So maybe it doesn't, unless it's like saying 3-year-old or something like that. I have trouble, but then that doesn't explain RL. So, yeah. Any ideas? Is there like some contraction or like something with apostrophes or something like that would separate YR or RL sung titles or something like that? Yeah, so I don't know, but that does look funny. Okay, so the other thing that we can do is we can keep going further, and we can add in trigrams. And so notice that if you just do trigrams by themselves, the accuracy goes down. So if you add in everything up to trigrams, right, so this is actually mislabeled. This is this. So if you do that, you get here, and so now the points are becoming even more annoying and omnipresent. So we really do need to get rid of those. But we are seeing interesting things. So like this river, of this river was built, yada yada. So these seem like good phrases that we're finding. And then you'll notice in literature it's focusing on individual words that look quite a bit better than it did in just the unigram case where you had things like Jew hanging out by themselves. These words actually look quite good. Anyone see anything else that they want to mention? Yep.
Well, it looks like we're making these features more complex, but we're really only increasing accuracy by very small amounts.
Yeah, and so don't feel bad about that. That's the way it always goes. And so the first thing you try will work pretty well, and then every additional thing that you do just makes it harder and harder. So like it's the 80-20 rule, and so the first thing you try will get you 80% of the way there, and then that last 20% will take another 5 years.
Is there some kind of discounting going on, like the regularization, that might make us dissuaded from using this more complex depiction of it?
Yeah, I mean, that's part of it, but part of it is also that if you just use individual words, you can do a pretty good job. It's, if you see writer in a 5 times in a question, it's probably going to be literature. And everything that we're adding in doesn't move it that much. Yep.
What about something like named entity recognition, right?
Yeah,
proper
right.
nouns, people's names, place names are going to be more particular to science, math, literature, etc.
Yeah, exactly. That's a good point. Anyone else see stuff here? Yep.
I was just wondering, I mean, at some point, I would guess that if you just keep going up with doing, like, up to engrams, and it gets really big, eventually you're just going to start characterizing the entire, like, corpus. Like, I know if you do this with Shakespeare's works, you end up with an engram that is just the size of the corpus, and that's the best fit. And so, like, at what point do you say that, like, I have 15 grams? Is that enough? Like, how do you make that decision?
Yeah, so this is held out accuracy, so this is not on the training set. This is on a held out set. And so you should watch this, and at some point this will plateau, and I think we're pretty near there. So we went to 0.803 to 0.809, and maybe adding 4 grams will get us to 0.81, but we're not making huge leaps and bounds here by increasing the length. Yep.
It looks like this is very syntactical, so we're not really caring what the actual word is, only that we've seen it. Any way of altering this to incorporate the semantics, so you might not only have emperor, but you would have a scattering of dictator and president as well, and that might increase the ability to.
Yeah, and so you can use words like, tools like WordNet to try to capture relationships between words and things like that. And you can look up and do things like query expansion, and so you can query emperor and then ask what are the words most similar to emperor. And another way of doing that that's a little more modern is word2vec, which is another tool that you can use to do that sort of thing. Okay, so another thing that you can do is forget about the words, and you can use character engrams. And so this is character engrams of up to length 7, and this actually does pretty well. So forget about the words, and you can get a pretty good classification. Yeah, so this is a little bit harder to read, but literature doesn't look all that different, except we're adding in quotes. And
white space.
Yeah, and lots of white space. And so, yeah, so RL seems to be appearing at the beginning of quotes, or sorry, at the beginning of parenthetical expressions. So I don't know why that is. This is weird. So something's going on there. So anyone else? And one nice thing here is that chemistry learns like words that end with inium are chemistry terms. So that's nice. And words that begin with chemi are also related to chemistry. So it's doing some of the lemmatization that you wanted to do, and I never did, just by itself. Yep.
Like there are control characters in here after sign.
Yeah, there's a new line character.
Yeah, maybe, and so. Yeah, and so these are marking when the question suddenly gets easy. So like if you answer it before this sign, that means you get bonus points, and if you answer it after this, you get bonus points. And I suspect that this is because of the way we mapped from this category initially. So other observations? The one thing that surprised me is that this did so well on accuracy. So this is doing about as well as the trigram model, but it takes a lot less space. And so one thing that I didn't do is try to combine character engrams with trigrams. And the question is, are they learning the same thing or different things? And so maybe the overall accuracy would be better. So that's another moral. So what I want to end the class with is break into small groups and talk to your neighbor. What else could we be doing? Be as imaginative and creative as possible, and talk to your neighbor about what other features you could use, and then we'll reconvene, and everyone can share their ideas.
So what do you got?
Like Charles the First, Edward the First, so like kings.
Okay. I think it will be like 1-1 and I double I then.
Yeah, exactly. But this is the one. There are more. For every second, you have a first, so there are more of them.
Or a plus. This one, bracket of plus.
Okay, that you got me. I have no idea.
That's interesting.
So you mean say
Yep. Just don't quite understand what is character.
Right, so instead of breaking things by spaces at words, just look at the individual characters in a word. So like chemistry starts, so any substring, so like the space and then chemist, and so all strings of characters, not strings of words, up to at most 7 characters. So using all of those as features.
Okay, I see. And by using this, you get accuracy.
Yeah.
Okay, so it's like regular expression, like.
But simpler than that. Just take a sliding window through the string, and every set of characters becomes a feature. Okay, so what do you got? Yep. So special symbols, what do you mean?
For example, very special symbols in chemistry, heat and something.
Oh, okay, yeah. So like look for mu and things like that. Okay, yeah, that'll be ignored, yes.
Similar to that, it would be look for equations.
Okay, yeah.
There's some things that may be common in physics and common in chemistry, math, etc.
Yep, equations. Nice, yep.
I was thinking that if you were, if you came across a word that you didn't know what it was, you could like run off to some API and find out what the synonyms were, and then add that word to the category that its synonyms were in.
Mm-hmm.
So then you don't have to do that again.
Yep. Yep.
More derived information, we were thinking parts of speech and etymology. You could have like...
So how would you encode etymology as a feature?
We're thinking with parts of speech you could have weights.
Mm-hmm.
Which categories are more likely to have parts of speech?
Yeah, sure. That sounds good, but I'm more intrigued by the etymology. So how would you encode that as a feature?
Well, you could look at diversity of etymology, and literature is probably going to have lots of diversity. Math is going to be centered around certain areas.
Mm-hmm. Yeah, so I guess you could query the OED or something like that, and and then maybe have like the total counts of all of the origins in your document. Yep.
Maybe there's like some keywords that you can, if you see the keyword, you look after it, like, when, you're probably going to be looking for a date.
Yeah. Right, yeah. And in fact, in these questions, this tends to be a keyword, and so you say this English author, this Russian battleship, and so on. So those sort of tell you what your answer is going to be. So that's a good insight. Yep.
Diagrams that don't necessarily need to be adjacent, but could just co-occur in the same sentence. So kind of.
Yeah, right. So these are called skipgrams. And that's a great idea, but hard to implement in an efficient way. Yep.
One way we were talking about in implementing skipgrams would be to filter the data set by parts of speech. So you have nouns and verbs with lights. Exactly.
Yep. So I overheard someone talking about quotes, and that's a good idea. So like. Suck in Project Gutenberg and Wikipedia and look for overlapping sequences of long strings and see where that came from. And so if it came from a history book, then it's more likely to be history. If it came from Project Gutenberg, it's more likely to be literature. Yep.
Of course, then don't you then have to classify all of the books and Wikipedia articles that you
Yeah, but the nice thing about Wikipedia is it has categories at the bottom of the code, so you can use that. And so like the one mechanistic way to do that is find a quote, look it up in Wikipedia, throw the categories in as features. And then the classifier learns what categories map to what categories. I thought I saw... Okay, so when I used to have this as a feature engineering assignment, so people did exactly that, the Wikipedia categories. So when I taught this course at Princeton, there was one kid who would just not give up. And so he looked at the process for how these questions are written. And so these are written by writers on a contract, and they have quotas. And so if you have the timestamp when the question was written, you can figure out, okay, so on this day, this person had to write this many history questions, this many literature questions, this many other questions. And so I did not provide the timestamp, but he asked, can I add the timestamp? And I said, sure. Why would the timestamp help you? And so it did. And so what you can do is you can do an initial classifier over all of those questions, and then some of these you'll be more sure about than the others. So you basically do a linear program to see what way you can match the quotas and is most consistent with your classifier. So that was really impressive. So as someone else mentioned, you can pay attention to syntax, and so the words after this are more important. Right, and so going back to this, different authors have different quotas, and so if you're able to download the quotas, you can see who wrote it, whether they had in their contract more questions for sports versus literature, and you can use the identity of the author to help you with that. Yep.
So different, like, are we working with only one, like, trivia set manufacturer? Because obviously these would change.
Yeah, so it does rotate, but they all operate under similar systems, and so.
So it's not overfitting?
This guy did really well, so it seemed to work. Okay, so any other ideas that have come into your brains? Okay, so this should get you ready to do homework 3, but as I warned you, it's very different from homework 1 and homework 2. At the same time, class will be very different. We're now going to embark on very mathematical stuff. So I do really encourage you, especially if you're watching and not attending class, to actually come to the discussion sections next time. We're going to be working through some mathematical stuff that it really does help to be in small groups working through with other people. So please do make a point of coming for the next 2 or 3. Well, you should always come, but especially come for the next 2 or 3. This trips up a lot of people. They think, aha, yeah, I can program, I got this, but we're getting to some more mathematical stuff that often trips people up, so don't let that happen to you. Be prepared and be ready to work through some proofs and some geometry starting next week, or next session and also next week. All right, thanks, and I'll see you then.